Let's start by assuming that the fixed point O described in the problem statement is the origin. Let's assume that the equations of the n fixed straight lines b, y is equal to m1x plus c1, y is equal to m2x plus c2, and so on till y is equal to mn times x plus cn. Now, since these are fixed straight lines, therefore m1, m2 and so on till mn and c1, c2 and so on till cn are also fixed. Now, let the equation of the variable straight line passing through the point O or the origin be y is equal to mx. And let's assume that the coordinates of the point are b, h, k. Now, since point R with coordinates hk lies on the line y is equal to mx, it follows that k is equal to m times h, and therefore m is equal to k upon h. Now we'll determine the coordinates of the point rj, which is the point of intersection of the line y is equal to mjx plus cj and the line y is equal to mx. Equating the value of y from both equations, we get mx is equal to mj times x plus cj, and therefore x is equal to cj upon m minus mj. Therefore, y, which is equal to mx, is equal to cj times m divided by m minus mj. Therefore, the coordinates of the point rj are cj upon m minus mj and cj times m upon m minus mj, where j is equal to 1, 2, 3 and so on till n. Therefore, the distance ORJ is equal to square root of cj upon m minus mj minus 0 whole square plus cjm upon m minus mj minus 0 whole square, which simplifies to cj upon m minus mj multiplied by square root of 1 plus m square. And the distance OR is equal to square root of h minus 0 whole square plus k minus 0 whole square, which is equal to square root of h square plus k square. Now we're given that n upon OR is equal to 1 upon OR1 plus 1 upon OR2 plus and so on till 1 upon ORN. Substituting the results obtained earlier, we get n upon root of h square plus k square is equal to summation j going from 1 to n m minus mj divided by cj times root of 1 plus m square. Now we have determined earlier that m is equal to k upon h. Therefore, the above equation becomes n upon square root of h square plus k square is equal to summation j going from 1 to n k upon h minus mj divided by cj times square root of 1 plus k square upon h square. And this is equal to the summation j going from 1 to n k minus mj times h upon Cj times h times square root of h square plus k square upon h square. H cancels in the denominator of the right hand side, and therefore the above equation becomes n upon square root of h square plus k square is equal to 1 upon square root of h square plus k square multiplied by summation j going from 1 to n k minus mj times h upon cj. Root h square plus k square cancels across the left hand side and the right hand side in the denominator, and we therefore get n is equal to k times summation 1 upon cj minus h times summation mj upon cj, where j goes from 1 to n. Let's assume that the first summation on the right hand side, summation 1 upon cj, is equal to a, and let's assume that the second summation on the right hand side, summation mj upon cj, is equal to b. Note that both a and b are fixed because mj and cj are fixed for all values of j equal to 1, 2, 3 and so on till n. Therefore, the above equation can be written as n is equal to ak minus bh. Now the locus of the point R with coordinates hk can be obtained by replacing h with x and k with y in the above equation. Therefore, the required locus of R is ay minus bx is equal to n, which is a straight line. And this is the required result.